All right, today we're going to graph quadratic functions and we're going to graph them from standard form. So just recall that standard form right there. In order to graph, we're going to need some pieces of information. So the first thing we'll want to find is our axis of symmetry, and recall this is a formula to find that axis of symmetry. We'll want to use that axis of symmetry to help find our vertex. We also generally can find our y-intercept fairly easily. And then we're going to pick some points that are symmetric to the vertex. So we're going to go through a couple examples to see what this looks like. So here's our equation. We need to graph this parabola. First thing we need to find is the axis of symmetry. So we use that opposite of b over 2a. Well, opposite of b over 2a is negative 4 over 2 times 1. That simplifies to be negative 4 over 2, and then we get a negative 2. Now, this is the axis of symmetry, but it is also the x value of our vertex, since our vertex always goes through our axis of symmetry. So I'm going to take this x value and plug it in to my original equation for x in both of these places to get my y value. So to find my vertex, I'm going to take that, just like I said, take that negative 2 and plug it in for x. So we get a negative 2 squared plus 4 times negative 2 plus 5. Simplifying that, that becomes a positive 4 minus 8 plus 5. Altogether, that's a negative 1. So our vertex is negative 2 comma negative 1. Then I can also find my y-intercept by plugging 0 into my equation, because remember, your y-intercept is always on your y-axis, which means your x value is 0. So 0 squared plus 4 times 0 plus 5, those are both 0, leaving us with 5. So I'm going to create a table. Notice I put my I put my vertex right in the middle of this table because that's the center of our graph, or the middle of our graph. Then I'm going to pick points above. I'm going to pick points to the right, and I'm going to pick points to the left. So when we take negative 1, we plug that into our original equation, and that's where we get the 2. When you plug 0 in, we get 5. That's our y-intercept right there. Okay, then we're going to go to the left of our vertex and take negative 3 and plug it back into our original equation. When we plug negative 3 in, we get a 2, and when we plug negative 4 in, we get positive 5. When we go to graph that, there is a sketch of our parabola. Couple things: vertex, axis of symmetry would go straight through that. This is a parabola that opens upward, therefore our vertex is a minimum. Okay, we'll do one more example. We're going to graph 3x squared plus 18x plus 13. Again, the first thing we need to find is our axis of symmetry. So we take opposite of b over 2a, which is negative 18 over 2 times 3. That simplifies to negative 3. Then we take that and plug that in for x into our original equation, because that will give us the y value of our vertex. So 3 times negative 3 squared plus 18 times negative 3 plus 13. We get our vertex to be negative 3 comma negative 14. This leads us to our table. We can always find our y-intercept by plugging 0 in. Well, that would become 0, that would become 0, so we know our y-intercept will be 13. So when we go to make our table, remember your vertex is that center point. We picked 2 points to the right, 2 points to the left. I went ahead and chose 3. The more points you have, the more accurate your graph is. So we plug in all of these x values and get these corresponding y values. If you notice, here's our vertex. The point just above and below have the same y value. The points 2 above and 2 below also have the same y values, and then also our top and bottom values have the same y values. That's because our parabola is symmetric. So here's a sketch of that parabola. Symmetric, remember, means you can fold it in half and it would be a reflection, which is exactly what this is. Okay, our axis of symmetry is that line of reflection. And then I would also like you guys to just practice by graphing 5x squared plus 4. Notice you don't have an x term, so your b value would be 0. So practice that graph, please.